Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at how to use the first principle to differentiate a function. So without wasting much time, let's get started. So to actually differentiate a function using the first principle, we have the formula given to us by dy over dx, which means the differential, or f prime of x, okay, is equal to what? The limit as h approaches 0 of the function f of x plus h minus f of x all over h. Okay, so this, okay, from here all the way here is actually the formula for the first principle derivative, and then this means the differential of the function x. Okay, so now let's dive in and see how to use this formula that we have over here, which is the limit as h approaches 0 of the function f of x plus h minus f of x over h, to solve a problem in case we are given one. So I hope you've copied down this formula and let's get started. Okay, so the first example we have over here, we are to differentiate the function f of x is equal to what? S squared, using the first principle. Okay, so in instances where we are given questions like this and we are supposed to use the first principle, first thing we need to do is what? To code down the formula for the first principle, which is what? The f prime of x is equal to what? The limit as h approaches 0 of the function f into bracket x plus h minus f of x all over what? H, and then we have our bracket closed. Now to solve this on an easier scale, first let's take the first term over here, which is the f of x plus h, and then we solve it separately. We take the f of x separately and then we combine all of them together with the formula to get our answer. So let's do that. So the f of x plus h will give us, what this simply means is that the function you are given at the top over here, wherever you see x, replace it with what? X plus h. That is the simplest meaning I can give. So we have s squared over here, so instead of s squared over here, because we are dealing with f of x plus h, we will be putting what? X plus h in place of the x over here, and then we square them and then we get the answer we want for the first term over here. So in this example it is going to be s plus h all squared, and this will give us what? S squared plus 2sh plus what? H squared. Now that is for the first part. Now the f of x, okay, which is the second term, simply means wherever we see s, let's put what? S over there. Okay, so in this instance we only have, in place of s, if we replace s with x again, it will still be s, so we have s squared. Okay, so now that we have these two terms over here, okay, we can input them back into this formula and we get our answer for this question. So we have over here the limit as h approaches 0, okay, is equal to what? Then into bracket, then in place of f of x plus h, we are going to be putting what? S squared plus 2sh plus what? H squared. Then in place of f of x, you'll be putting s squared, so we have minus what? S squared, then all divided by the h, which is over here, then we close the bracket. So from here we can see that we have negative s squared over here, and then we have s squared over here. Okay, so these two will cancel out, so we have the limit as h approaches 0, then we have what? 2sh plus h squared all over h. Okay, now from here, because we have h over here, this is more like 2sh divided by h, and then we have plus h squared divided by h. Okay, so the h's will cancel out. Okay, so the h will cancel out the h over here, and then the h here will cancel one of the h's over here, so we have limit as h approaches 0 of what? 2s plus h. Okay, so from here all we need to do to get rid of the limit is what? To put the value what? 0 in place of h, and then we will get our answer, or the limit to go. So over here it will be equal to what? 2s plus what? the h will now become what? 0. Okay, so our final answer for this example, this particular one, is equal to what? 2x, which means if we differentiate the function s squared, we are going to get what? 2s as our answer. So the limit of the function s squared as what? H approaches 0. Okay, the value of x that we will get when h is approaching 0, okay, is what? 2s. And that is what the first principle of derivative, or the differentiation of a function, normally helps us to find. So let's have a look at another example. So example number 2, we are to find using the first principle of derivative, we are to differentiate the function 2s squared plus 4x minus 3. So how do we do this? Now, as usual, you are supposed to use the first principle. So we code the formula, which is what? F prime of x is equal to the limit as h approaches what? 0 of the function f of x plus h minus what? F of x all over h. Then we close the bracket. Okay, so from here, okay, as usual, let's take out our first term. So we have our f of x plus h is equal to, which means over here, wherever we see x in this question, okay, let's put what? S plus h over there. Okay, so in place of x over here and then x over here, we'll be putting what? X plus h in place of this s over here. So what are we going to get? We'll be getting 2 into bracket x plus h squared plus 4 into bracket s plus h, then minus 3. So we then simplify. So we will have 2 into bracket s squared plus 2hx plus h squared, okay, then plus 4h plus 4x 4h, then minus 3. So from here we can get what? 2s squared plus 4xh plus 2h squared, then plus 4x plus 4h minus 3. Okay, because we don't have any like terms again over here, we tend to stop here because there's nothing we can either add or subtract or cancel out over here. So this means we are done with the first part of the term in the formula. Now let's have a look at the second term. The second term is telling us f of x. Okay, so which means wherever we see x in this equation, let's replace it with x. Okay, so normally this is the same as the function that we are given, so it doesn't really change anything. Okay, so in place of x over here we still have x, so in place of f of x over here we will be repeating this whole question over here. So we have 2x squared plus 4x minus 3. Okay, so now let's further simplify this. So to get our f of x plus h minus f of x, mind you, the fact that we are solving just this part of it means the limit as h approaches 0, and then the h, we are reserving it and we'll be using it later. So don't forget it when you are taking this step by step. Okay, so it means in place of everything over here, everything we have over here, which is for the x plus h, you'll be writing 2s squared plus 4xh plus 2h squared plus 4x plus 4h minus 3. Okay, then this is 3, then minus into bracket. Okay, now the f of x over here will be this guy, so we will have what? 2s squared plus 4x minus 3. Okay, then bracket close. This is open bracket. Okay, now this is equal to what? We still have the 2s squared plus 4sh plus 2h squared plus 4x plus 4h minus 3 over here. Now the negative outside this function, okay, will affect everything in the bracket. Okay, so we have minus what? 2s squared, then minus 4x, then plus 3. Okay, so from here we can see that this negative, let me let me bring this negative down here. Okay, so we can see that we have positive 2s squared over here, and then we have negative 2s squared over here. So this will cancel this. Okay, we have negative 4s over here, and then we have positive 4s. We have 3 here, we have negative 3 here. So it means the function f of x plus h minus f of x will give us what? 4sh plus 2h squared, then we have plus 4h. Okay, for everything at the top over here, which means just solving the top, everything at the top over here, this is what we are getting. Okay, so if that is what we are getting, then let's quickly get some space and then we continue solving our example. So it means from here we can now put the formula limit as h approaches 0 into bracket. In place of everything we have at the top over here, that is what we solved over here. So we'll be having what? 4xh plus 2h squared plus what? 4h, all divided by what? H. Then we close the bracket. Okay, sorry. From here we can see that we have h, okay, and then we have h as the denominator, so the h will cancel all the h's over here. So the h will get rid of this h, the h will get rid of one of the h's over here, and then the h will also get rid of another h over here. So we are going to be having limit as h approaches 0 of what? F of x, okay, 4x, sorry, plus 2h, okay, plus 4, which means the h has cancelled the h, so we don't have the h over here again. The h has cancelled one of the h's over here, which means we are still left with 1, and then the h has cancelled the h over here, so we are left with nothing. So to actually get the final answer, okay, all we need to do is to put the value h is equal to 0 into this equation over here, and then the limit will be gone, and then we can get our answer. So we'll be having 4x plus 2 into bracket 0 plus 4, okay, which is equal to what? 4x plus what? 4 as our answer. So it means when we differentiate the function f of x is equal to what? 2s squared plus 4x minus 3, we will be getting what? 4x plus 4 as our answer. So this is how we used the first principle to actually differentiate a function given to us. So first of all, you have to make sure you get the f of x plus h term, okay, and then you get the f of x term, you subtract them, and then you divide it by h, and then you apply the limit as h approaches 0. So whenever you are given a function like in this example, all you need to do is what? Take the f of what? X plus h, okay, sorry, and then wherever you see x in the form in the question over here, you put what? X plus h over there, x plus h, as we did. Okay, you solve that one, and then you have the answer, you note it somewhere, and then minus f of x, which is normally the question, so you repeat the question again, then you subtract these two, whatever you get, you divide it by h, and then you apply the limit as h approaches 0, and then you get your answer. So thanks so much for watching, and I hope you've learned something, and this helps you facilitate how you see or solve the differential questions using the first principle of the derivative. So thank you so much for watching, and then I'll see you in the next video. Bye bye.